Hello and welcome to another geometry lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 4, Lesson 7 on constructing rotations. So in this unit we've been working on various constructions, right? Parallel line constructions, perpendicular line constructions, angle bisector constructions, okay? And we've also used those constructions to construct both translations at this point and line reflections. Today we're going to see how to construct certain rotations. Now we're not going to be able to construct a 32-degree rotation or a 71-degree rotation, all right? But we will be able to do some types of rotations using the tools that we already know with constructions. So let's get right into probably the easiest of all rotational constructions. All right, constructing rotations. We've now seen how to construct translations and line reflections. In this lesson, we will learn how to construct a limited number of rotations. Limited number. Let's take a look at exercise number 1. Maybe move my ruler out of the way. Let's take a look. Given segment AB and point C, letter A, construct the image of segment AB after a 180-degree rotation about point C. Okay, so 180-degree rotations are the easiest rotations of all because, recall, if I take point A and I rotate it 180 degrees about point C, then what happens is A, C, and A prime must be collinear, right? So that's where we begin. In order to rotate point A about point C, what I'm going to do is I'm just going to simply draw a line that passes through point A and point C. Right? Somewhere along that line, A prime must lie. Now obviously, with rotations, what happens is that the image point ends up being the same distance away from the center point as the pre-image point, right? Because the pre-image and the image point both lie on a circle that is centered at point C. So to figure out where A prime lies, I bring my handy dandy compass in, I put the center at point C, I move it out, I measure the radius to point A, and then I'm going to use that on the other side to find where the image of point A lies. So there is my A prime. Simple, right? Very, very easy. I'd like you to pause the video now and figure out where the image of point B lies, right? Where B prime lies, and then connect A prime and B prime with the segment to get our image segment. All right, so first things first, let's draw a line that passes through point B and point C, our center of rotation. I think I'll stretch this out a bit. Okay. Somewhere along that line, our image point has to lie. So again, I'll now put my compass at point C. Maybe reverse it. Figure out the length to point B. And then again. And now we have the location of B prime. So now I can take my exceptionally long ruler and connect A prime and B prime to have my image segment. Look at that. Beautiful, right? I've taken AB, segment AB, rotated it 180 degrees for segment A prime, B prime. Okay, little follow-up question on here. Letter B. A 180-degree rotation about a point is also known as what special type of transformation? All right, pause the video now and see if you can remember the other name we give to a 180-degree rotation about a point. All right, this is what's known as a point reflection. Point reflection. If we really wanted to get technical, we'd call it a point reflection through point C. And it kind of holds with how we want to think about a reflection, even a line reflection, right? With a line reflection, the idea is we take a point, right, the pre-image point, we move perpendicular to the line of reflection, figure out how much distance that is, and then move away from the line of reflection the same distance. Well, with a point reflection, the idea is, right, we take point A, we move it into point C a certain distance, and then we move it out of point C the same distance, right? So that point A is the same distance away from point C, right, but in the same direction on the other side. Same thing with point B and point B prime. So point reflections and 180-degree rotations about points are the same transformation. And you could be asked on a state exam or on a local exam or something to do a construction that is a point reflection, and that would be the same as a 180-degree rotation. All right, so now we've gotten the easy one out of the way. All right. Let's now take a look at rotations by 90 degrees. These are more difficult. Now, we can rotate points by 90 degrees about other points by using a perpendicular line construction, right? Perpendicularity is all about 90-degree angles, and so we'll use one of our perpendicular line constructions to help us locate images of points after we've rotated them by 90 degrees. We just have to really pay attention to which direction. Let's take a look at exercise number 2. Given points A and C below, we would like to rotate point A about point C in the counterclockwise direction by 90 degrees. Letter A, draw line AC. All right, so the first thing I'm going to do when I rotate a point by 90 degrees about another point is I am going to draw a line through the 2 points, okay? And we'll talk about why this is in a second, but let me just kind of get this line drawn. And I actually want that line to extend a decent amount past the point, the center point of rotation. All right, so that's the first thing I'm going to do. Now, side note, I want you to always kind of visualize where the final image point is going to be, right? I'm going to take point A, and now I'm going to rotate it by 90 degrees counterclockwise about point C. So point A is going to be somewhere up there, and it's going to be along a line segment that is perpendicular to that line and passes through C. So of course that's going to be the second part of our construction. Let's take a look at B. Construct a line perpendicular to line AC that passes through point C. All right, so we did this construction a few lessons ago, right? And it was part of our lesson on how to bisect an angle. Because what I'm really doing now is I'm going to bisect the 180-degree angle that is centered at C. Let's remember how to do that. What I'm going to do is I'm going to bring my compass up and I'm going to put it center at C. I am then going to draw an arc, okay, on either side of C that has the same radius. Okay, what I'm doing there is I'm locating 2 points that are equidistant away from point C. Now what I'm going to do is I'm going to bring my compass over to point A, to one of those intersection points. I'm going to make it a little bit bigger, and I'm going to draw an arc with that radius up here. Then I'm going to switch it, and I'm going to have all sorts of stuff coming out on my screen. And I'm going to draw with the same radius an arc centered at the other intersection point. And now, X marks the spot. I can now draw a line that passes through point C and the intersection points of those 2 arcs, right? What I know for certain is that that now is a 90-degree angle. Okay, so somewhere along this particular line segment, my image point has to lie. So let's look at the last part of this, letter C. I lost this entirely. Let me move this out of the way. Let's take a look at letter C. On the line you drew from B, locate A prime, the image of A, after a 90 degrees counterclockwise rotation about point C. Awesome. Well, what we know, let me move this up a little bit so we can actually see where we're going, is that what I'm going to do with any rotation is I'm going to center it at C, and I need to rotate A along a circle with a center at C and with a radius of CA. That's easy now, right? Because what I'm going to do is I'm going to put my compass point at C. I'm going to move the compass out so that it's got a radius of CA. I'm going to come close there. That's pretty good. I'm going to mark that. And if you really wanted to, you could just do it all the way like this. At least in this particular construction, since there's not too much going on, right? It's not bad to have that entire arc like that, because you can really see how point A simply moves along a circle, right, centered at C, until it eventually intersects that line that is perpendicular to the line passing through CA. And there we have it. We've just rotated point A by 90 degrees counterclockwise about point C. So it's a little bit involved, but probably the hardest part, if there is one, is simply creating that perpendicular line, right, that is perpendicular to the line that connects C and A, our center of rotation, and the point that we're trying to rotate. All right, let's keep working with this a bit more. Let me just make sure I don't have anything else in this problem, and I don't. So let's keep going. Exercise 3. Construct the rotation of segment KL around point M by 90 degrees clockwise. Leave all construction marks. Okay, so what we're going to do now is we're going to be taking this segment and we're going to be rotating it 90 degrees clockwise, okay? Now, obviously what we're doing here is we're really doing two of the constructions that we just did. We want to rotate point K and we want to rotate point L. So this picture is going to get a little bit ugly, okay? Let's do the first one together, and I say we do the more challenging one, I think, of the two together, which is rotating point L by 90 degrees about point M. So, right, it's going to end up being somewhere out here, okay? So let's review how we do this. Okay, totally ignoring both K and line segment KL, I'm just going to come over here and I'm going to draw a line that passes through L, right, and M. Okay, now what I want to do is I want to create a perpendicular line that passes through M and is perpendicular to that line. So I draw my two arcs like that. Okay, now I'm going to make my, oops, I'm going to make this a little bit bigger. And I got to just get it on that intersection point. There it is. All right, make an arc like that. Switch the location, put the pointy end of the compass now here. And try to get it on that intersection point. There we go. And now we've got the location that will allow us to draw that perpendicular line. So, X marks the spot. Okay, so what we now know is that the image of point L must lie somewhere along that line segment that I just drew. So let's figure out how far L is away. Almost. There we go, not bad. Actually quite good. And there it is. So L prime must be at that location. Okay, so I just found L prime, right? And again, very simple. Right, I draw a line from the pre-image point through the center of rotation and past it. I then construct a perpendicular line through the center of rotation, okay, in the direction I want. Since I'm going clockwise, I want it in this direction. If I was going counterclockwise, I'd actually want to extend it in the other direction. And then I simply just use my compass to figure out how far the pre-image point is away from the center point, and then that helps me locate the image point, which has to be the same distance away. Okay, I'd like to see if you can do the same thing with point K, figure out the image of point K prime, right, or the image of K, which is K prime, and then connect L prime and K prime to find our image segment. All right, let's do it. Here we go. So again, I start by simply drawing a line through K and M. This picture is going to get very busy very quickly. Very busy very quickly. I like that. All right, here we go. That's enough. Okay, now I'm going to bring my compass over. Eventually I'll get it there on M. There we go. Now I need to construct that perpendicular line to the line I just drew. Get those two arcs. Oh, well, or maybe that full arc. All right, now we'll bring it over here. I didn't really necessarily want that full arc, but there's nothing actually wrong with having it. There we are. Switch. And bring the pointy end over here. Oops, good. I'm glad it didn't actually draw because the center had slipped. There we are. X marks the spot for now. Bring my ruler over. Get that perpendicular line segment in there. Almost. There we are. Somewhere along that line, the image of K must lie. So let's get it on there. And let's open it up. Figure out the distance to K. There it is. I'm going to just draw partial arcs here because it will keep my picture a little bit cleaner. There is K prime, and now let's connect the two with a line segment. And there it is. There is K prime, L prime. Okay, that was quite a bit of work, right? And again, you know, it's a little bit unsatisfying for me compared to the 180-degree rotation because it's a little bit harder to just see that this is a 90-degree rotation of this one, but it certainly is. And again, the key to 90-degree rotations is the ability to create a perpendicular line passing through a point that lies on a particular line, right? That particular construction, now we've seen again and again. All right, so let's keep going and look at some other types of constructions. Now, sometimes we have to think carefully about how to rotate by a specific angle and use multiple constructions. So far what we've really done, especially with the 90-degree constructions, is just that one particular construction, constructing a perpendicular line through a point that lies on a line, okay? But now let's take a look at one that might require a little bit more thinking. Exercise number 4. All right, here we go. Construct a rotation of point K around point C in a clockwise direction by 45 degrees. Leave all construction marks. All right. Well, here's the key, right? You have to know that 45 degrees is 1/2 of 90 degrees. You have to know that, all right? So 45 is a very special angle. It's half of 90 degrees. So if I can construct a 90-degree construction, right, then I should be able to bisect it using my angle bisecting construction, which we looked at a few lessons ago, to figure out a 45-degree construction. All right, so let's take a look at how that might be done. Let's do it. Now again, we're going in a clockwise direction, so the first thing I'm going to do is actually pretty much exactly what I've done in the last few constructions. I'm going to construct this 90-degree. First, I'm going to draw a line from my image point through my center point, and then I'm going to construct a perpendicular line through that line centered and that passes through point C. Okay, so this is going to look awfully familiar to what we just went through. All right, so I make that, and I make that. Now we'll bring our compass over here, widen it out a bit, and we'll draw that arc. And now let's switch it, leaving the same radius. We will now draw this arc. Ooh, I almost missed. And now let's get that perpendicular line. Now, I don't need to do the second part of the constructions that we just did. I'm not looking for K prime to be on this, not at all. In fact, the only reason I did that, right, the only reason I wanted that 90-degree angle was so that I could then go ahead and bisect it to get my 45-degree angle. So now let's review how you do an angle bisector construction. All right, step one with an angle bisector construction, I am going to put the pointed end of the compass at the vertex of the angle that I'm trying to bisect, and then I am going to draw an arc that passes through the two rays of my angle, in this case an arc that passes through the two rays of that 90-degree angle. I will then go up to one of the intersection points and draw another arc centered there, go to the other intersection point, try to go to the other intersection point, there it is, and draw another arc, and then that X marks the spot that if I connect it with the vertex of the angle, there it is, then I will bisect my angle. We're going to be doing a lot of angle bisectors in the coming lessons, so it's a good one to review. And now keep in mind, right, that both this angle and this angle are both 45-degree angles. In fact, I'll throw a little 45 degrees here and 45 degrees there. You don't have to do that. I'm just trying to illustrate a point. So finally, what was I trying to do? Oh, that's right. I was trying to find the image of point K after a 45-degree rotation, clockwise rotation, about point C. So if I now just rotate point A along a circle, right, centered at C with a radius of CK, wherever it hits this particular ray is where my image point's going to lie. So pretty easy at this point, right? I bring my compass down, set my radius length to be CK. Oh, perfect. In fact, I'll just kind of like draw that arc through it like that so that you can really see it. And now I've got K prime. So definitely more involved than our 90-degree constructions, because I first had to do a 90-degree construction, and then I had to bisect it to get a 45-degree construction, right? And then I simply used my compass to locate point K prime so that it was the same distance from C that point K was. Kind of cool. Now, if you don't realize that 45 degrees is half of 90 degrees, this becomes a very tricky construction, obviously. And it's not that easy even if you do realize it. All right, let's keep taking a look at these special types of rotations. Exercise number 5. Construct the rotation of point S by 60 degrees counterclockwise about point R. Leave all construction marks. So a 60 degree, right? Now, a 60 degree is, well, it's 1/3 of 180, but it's not half of 90 or anything like that. So the key to a 60 degree construction of any type is the following, right? When you have an equilateral triangle, right? A triangle that has 3 sides that are all the same, right? The angles in that triangle are all 60 degree angles. So the real key to constructing a 60 degree rotation about a particular point is actually just constructing an equilateral triangle. Now you have to watch out, right? So we want to construct the rotation of point S counterclockwise by 60 degrees about point R. In other words, right, I'm going to be rotating point S by 60 degrees and it'll end up somewhere up here. So I really just want this, right? I want an equilateral triangle, and then this will be S prime, right? S prime will be somewhere up there. Now, equilateral triangles are literally, look back in your notes, they're literally the first construction we learned how to do, right? And they're simple, because in equilateral constructions, equilateral triangle constructions, all I'm really looking to do is create a 3-sided figure that has all the same lengths. Now, I don't actually even have to draw that segment in, but it's kind of helpful to see it, right? I'm going to measure the length of RS, and in fact, I could just do this all the way up, right? Now I can kind of flip this thing, put the point at S, and make that arc all the way up. And this then guarantees that I have an equilateral triangle. Now you might say, well, I don't see an equilateral triangle there. Well, that's okay. If you want to throw that in, I'd encourage you to. There's nothing wrong with it. Remember, extra lines are never wrong in construction, right? So if I really want to see my equilateral triangle, right, I can put it in just like that. Now, interestingly enough, right, the location of S prime is most certainly a 60-degree counterclockwise rotation about point R, but you could also say that that would be the location of a 60-degree clockwise rotation of R about point S. Okay, kind of cool. So the key for any 60-degree rotation will be the construction of an equilateral triangle. All right, let's take a look at one more that I think is quite challenging. Exercise number 6. We want to construct the clockwise rotation of point E around point C by an angle of 150 degrees. Letter A. First, sketch a diagram of what this rotation should look like. Consider how large it is compared to a straight 180-degree angle. All right, so I'd like you to sort of pause the video now, and I want you to think about what this looks like, okay? And I would even sketch out sort of where the image point of E should lie. Pause the video now. All right, well, simple enough, right? So I'm just going to, I think I'll just sketch it. I won't use the ruler, right? So here we go, right? We've got something like this. We're going to rotate point E. You know, maybe it's going to end up like right there, right? Because it's going to be counterclockwise. We know that this is going to be 150 degrees. And of course, if that whole thing is 180, then this is 30 degrees. Likewise, just as a side note, right, if I kind of think about perpendicularity, right, if that's 90 degrees, then this would have to be 60 degrees. All right, so I'm just trying to kind of get a feeling for what I can do here, right? Because I've already seen how to construct a 180-degree rotation, a 90-degree rotation, a 60-degree rotation, a 45-degree rotation, and besides the 45, they're all kind of here, right? A 90, a 60, a 30, right? A 180, they're all kind of there. So the question is, how do I ultimately do this construction? So, take a look at letter B. Write down your strategy for performing this construction. There are multiple methods for doing this construction. All right, so what I'd like you to do is pause the video now and see if you can think of a way to do this construction. All right, well, I can think of two different methods personally, okay? One method is basically to construct, right, to basically draw this line in, construct a 60-degree like this, right? So we just sort of like take E and C, construct a 60-degree angle like this, all right? Because we know how to construct a 60-degree angle. I just have to kind of draw an equilateral triangle somehow in. And then I just need to bisect, right, that angle so that this is 30 degrees. Really what I need to do is I need to construct a 30-degree angle, right? So that's one way to do it. Another way to do it would be, let's say, to construct a 90-degree, right? Because we've done that before, and then construct that equilateral triangle here so that you have a 60-degree, right? Therefore giving you a 150-degree. So to me, those are the two most straightforward ways of doing it. One way of doing it is basically constructing a 60-degree angle, then bisecting it to get a 30-degree angle, and therefore having that 150-degree angle. The other way is to construct a 90-degree angle, then construct a 60-degree angle, which gives you the 150-degree angle. Either way, you're going to have two constructions, okay? And I'll kind of show you them both. I'm only going to go through this one, but then I'll show you how this one looks as well. So let's actually do it. Let's do this one together, okay? So I'm going to construct the one where I basically construct this 30-degree angle. So here we go. First thing I'm going to do is I am going to draw a line segment passing through E and C just to establish that sort of 180 degrees. Now, remember, to get that 30-degree angle, what I'm going to do, and I want that 30-degree angle there, is I need to get a 60-degree angle that I will then bisect. So for a moment, I'm just going to totally forget about point E. I'm going to pretend it doesn't even exist. What I want is I want an equilateral triangle right here so I have a 60-degree angle. All right. Now, what should I use as the base of my triangle? Well, it doesn't really matter. I just need that 60-degree angle. So I'm going to make a mark like this. All right, let me move up a little bit. Using exactly that same length, I'm going to make a mark like that. And then I'll flip it and make a mark like this. I'm just kind of drawing an equilateral triangle. Okay, and then I'm just going to put a little point here. And I'm actually not going to draw the full equilateral triangle because there's really no reason to do that. I just want that 60-degree angle, right? So what I just did there was I got myself a 60-degree angle. Now, side note, right, this would be a wonderful way of having to rotate a point by 120 degrees, right? Because what remains here would be 120, right? So if for some reason they said rotate point E by 120 degrees about point C, then one great way of doing it is constructing the 60-degree angle because what you have left is 120 degrees. But now, again, keep in mind, what I want to do is I want to bisect that 60-degree angle. So I'm going to come in here. I'm going to do my angle bisector. All right, that means I'm going to put my compass like this. I'm going to try to put my compass like this. And I'm going to draw an arc that passes through both of the rays of that 60-degree angle. I will now bring my compass in here. Maybe lengthen it a bit. All right, I'll get that. And now put my compass there. Try to put my compass on that intersection point. Just isn't happening. And draw that arc. And now I will use the X marking the spot to bisect that 60-degree angle. Let's see. There we have it. Now again, I want you to keep in mind, right? What I've got here is I've got a 30-degree angle right here, which means this entire angle is 180 minus 30 or 150 degrees. Now, what I still haven't done is located point E prime, but I do know that point E prime must lie somewhere along that ray. So what I'm now going to do is simply use my compass to figure out where it should lie along that ray. So bring my compass down, center it at C, figure out the length from C to E, and maybe I'll just do this, right? And that will locate E prime. Wow, wow. Now, lest you think that that was the harder of the two, right? The other one would look something like this, right? In this one, what I've done is I've actually created that perpendicular line from E to C, or I've done that line from E through C. Then I've created the perpendicular that passes through C, that's perpendicular to EC, right? That then gives me this 90 degrees. And then I created that equilateral triangle up there, which is a little weird because then that equilateral triangle is kind of tilted in this way that for me makes it a little bit funny to visualize. But then 90 plus 60 is 150. And then I can figure out where C, I don't know why it says C prime, that should say I should say E prime there, but there you have it, right? There it ends up being the image point. All right, so two different ways of getting to that 150-degree angle. The bigger issue here, though, is using the various kind of constructions that we've learned in terms of a 60-degree construction, an angle bisector construction, a 90-degree construction, to somehow cobble together 150 degrees, right? And you can do that with so many different types of angles. Again, not all angles. There's no way you're going to be able to do a 42-degree construction or a 57-degree construction, right? Those aren't going to be within our abilities right now, or maybe ever. But we can construct ones that are 90, 60, 30, 45, etc. All right, let's wrap this up. So we've been able to construct basically any kind of translation or point reflection across a line, right? We can do that no matter what. With rotations, we're a bit more limited because we really have to work with our ability to rotate something 180 degrees or 90 degrees or half of 90 or 60 degrees due to equilateral triangles, or half of 60 because we can have an equilateral triangle and then an angle bisector. So we're really limited on what kind of constructions we can do when it comes to rotations. But one of the great things about these kind of constructions is they give you a lot of practice on other constructions that you've worked with in this unit. So make sure that you really kind of pay attention to the homework and work hard on it. I just want to thank you, though, for joining me for another geometry lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.